packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Hey, we wanted to do some follow-up on some listener feedback and questions. So let's just go ahead and jump right in and we'll tackle some questions that we've gotten from folks. And I think a good starting place is the ones about SMB. We haven't really covered a lot of SMB topics as of late. It's mainly been enterprise focused. So, listener points out there's a lot fewer resources for, small to medium-sized businesses as a general rule of thumb around sort of IT folks that are taking care of them. They may be managed service, things like that. And for smaller orgs, and they want to redo their local network, what do we think about around IPv6 and what time is the right time to adopt? And, are things actually ready to go for that marketplace? So I know Nick has all the answers. So I'll let him jump off first.
I can talk. I don't know if I'll say anything correct. Yeah. I don't know. I mean, I think that's a big question, like you've alluded to. In some ways, IPv6 can be easier because, you just turn it on and Slack does the work and everything gets a v6 address and, the users are none the wiser, right?
It's magic.
It's magic, right? And that's the way that in a perfect world, you got one service provider, a small business, let's say it's a sandwich shop or something, whatever. You turn v6 on, it's on the public Wi-Fi or whatever, and then nobody really knows or cares for that matter. That's easy, right? But I think it's when you get into the medium size that it starts to get more complicated, and especially when you're in the medium size market where internet connectivity is a core part of the requirement to do the business. That's where it starts to get complex. It gets deep very quickly in that space.
Well, I think there's the issue of smaller and medium-sized ISPs as well, because I know, there's a sort of general conviction, which isn't incorrect, that a lot of large ISPs have made the transition to IPv6 and are using it and making it available as part of their product and service offering. But, when you get down to the level of the smaller and medium-sized regional ISPs, I don't know what that landscape looks like in terms of IPv6 adoption. And so you may or may not have availability of IPv6 for your small and medium-sized business, depending on where you are.
That's a really important statement there, because I think it's all over the map when it comes to these medium regional ISPs. The small ISPs, it's strange because I've found that, at least in my experience, the really small ISPs are maybe more likely to have v6 because they just have zero IPv4,
right,
or they have 1/24 or whatever it is, and they don't have any options other than CGNAT and IPv6 native. I've personally seen it more in that space than in the mid-range. In the mid-range, you get folks that just did it because, it was just another thing to do and made their lives a little bit easier, and they could conserve what IPv4 space they have, a little bit better. And then you get the ones that are still stuck 15, 18 years ago where they can't spell it.
Yeah.
They've achieved no operational experience using IPv6 and therefore have not deployed it. I think that's accurate. I mean, getting back to the point around the small business side, I think one of the challenges for small to medium-sized businesses that maybe looks different than enterprise organizations is enterprise organizations are more likely to be running BGP and get PI space from someone like Aaron as a general rule of thumb. So if you fit in the Global 2000, you're definitely probably doing that, right? You're managing your presence on the internet in a much more company-first manner in terms of identity and address space, et cetera. And so you're more likely or more inclined or a little bit easier for you to maybe do v6 adoption. If you fit in that small to medium-sized space, but you still need to provide services in the same capacity like some of the bigger companies do, you may not be doing BGP and you may not have provider independent space. So how do you solve problems like redundancy, and how do you solve problems like which address space to actually utilize to run your organization? And in IPv4, it's relatively clear just because of the sort of past history of using RFC 1918, using NAT, making sure that you can sort of hide yourself behind a singular public IPv4 address space and overload that thing and be able to use it to get to all the common services that you need to consume from the internet. And you might use a a hosting provider or someone else to be able to provide the services that you need to push out for customers, et cetera. I don't think a similar model really exists for IPv6 in the same way and same simplicity, I should say, at the network layer to provide that. And so there's some debate about whether V6 is really appropriate for small to medium-sized business at this point in time, just because of that sort of shortfall. It's design and architecture. And I'm open to critique and questions about that one, but that's sort of my fast assessment of where I think things are at, which makes it a struggle because if you want to have any redundancy or high availability, which I think most businesses probably do, right? They don't want to drop off the internet. They don't want to not have access to the internet in order to be able to do the things that they need to do. I think that becomes problematic. And I think that's one of the areas where there's a lot of hesitancy for infrastructure engineers and network engineers and even consultants who are maybe in the SMB space that are doing managed services to be like, yeah, don't adopt IPv6 because we can't support you in the same way that we can support you with IPv4.
Which is a slightly different issue. To back up on that, my question would be, how are they accomplishing resilience and redundancy in IPv4 today? If it's just very much NAT-based, I mean, it kind of would push one to conclude that there's probably a solution in the direction of NAT with IPv6 in some fashion, whether that's NPTv6 or NAT66. But my first question would be like, what is the technique that SMBs are using today in IPv4 to maintain redundancy and resiliency?
Yeah, I mean, I think that's a resounding NAT 4.4. That's how they're doing it if they don't have PI space. One of the very first IETF drafts that I was involved in is called IPv6 Site Connection to Many Carriers. And it essentially was meant to just lay out what the current state of the art is on multi-homing IPv6. And it has all the options. It's expired. It was never adopted. But it is, I would argue, a fairly well-written document in that it lays out bare, basically, here are the things that exist today, whether they're standards or not. And this is what the landscape looks like. And I really wish that would have been adopted because I think it is a useful document. However, for varying reasons, it never made it past the draft state. I think we have 3 revisions of it, but it's worth reading for people that just don't know, like, what does it look like today if I want to do these things? Like, it was last updated a little over a year ago. No major changes have happened since the last publication of the draft. We can put a link to that in the show notes. But yeah, I mean, I think NAT's how they do it in V4. And I think that a lot of small businesses are comfortable with that. The industry did a very good job of conflating stateful packet filtering and inspection with address translation. And now there's a whole generation of IT people that don't understand that those are completely separate things. And so NAT 4.4 is what they're comfortable with. It's what they use every day. And there is no good analog for that in V6 that is, widely deployable.
Right. Yeah, I think that's the key point. That last section is the key part. Is it's very difficult to find even anything that's targeted to the mid to small business that has the feature requirements in there that you would need as an organization to be able to do the NAT translation if you chose to do that, or even any of the more sophisticated translation capabilities, right? Because even if you were to run your small business V6 only and you were on the V6 internet, and let's say you're perfectly comfortable using a single service provider, maybe they're providing you multiple links and they'll handle the failover for you and everything else, you still can't get to a whole chunk of the internet, right? Even though V6 is a 50% adoption portion for the internet, I guess that means that 50% you're not reaching because it's V4. So at that point, what do you do to solve that particular problem? And unlike the mobile providers, the commercial providers for small to medium business or even enterprise business, they don't provide a translation capability. They don't provide a hosted NAT64, DNS64. That's not something that is inbuilt into their network as part of a thing facing their customers. At least I'm not aware of anyone saying that this is the common way we go to market. They may have it, right? They might be able to provide it like cost fee or something like that. I think Cloudflare has some examples of some of that sort of stuff, but you're usually not buying your internet circuit from Cloudflare, right? They're providing you other capabilities. Yeah. So I think that's one of the big differences, at least to me, that's a standout. So it's very hard to be a V6 only, small to medium-sized business, at least domestically here in the US. And I'll speak to the US audience. That may not be true in other countries now.
Yeah.
It could be perfectly feasible to be a V6 only small to medium-sized business operating in certain countries because the only thing you have is maybe a mobile carrier that's providing all the service capabilities that you need to do to operate. And you may not even have a Wi-Fi network or other sets of infrastructure. You may be running around with, mobile handsets, and that's it. And that's perfectly doable.
Yeah.
In which case, a V6 only network would work just fine for you.
Yeah, I think that there is the model, which is basically a concession, right? If you want to run multi-homed at, some medium-sized business and you're dual stacked, your degraded failure mode could just be, I only have V4, right?
Right.
There's all kinds of problems that could pop up with that if your happy eyeballs applications don't act correctly, or, you're trying to get to a V6 only resource or what have you. But that is a perfectly supportable option. I have two providers, only one of them gives me V6, or they both do, and I choose to use only one of them.
I was just going to say, it kind of turns on its head a little bit, the idea that you've got this concern about resiliency and redundancy. And in a way, by having dual stack, you're solving that problem in a different way. I would kind of also argue maybe that that's an environment where maybe there isn't as much pressure to get IPv4 off of the network and to get to an IPv6 only posture quickly, because the amount of, in large scale networks, obviously, there's just a tremendous amount of effort and energy that has to go into maintaining the two protocol stacks and configuring them and administering them. In a small, medium environment, maybe that's not as onerous. Maybe it's something that just doesn't require as much of that sort of overhead. And so it's more tolerable and something that you're willing to live with to get that sort of quasi redundancy you're referring to.
Yeah.
I guess the challenge becomes you have different operational parameters for V4 and V6, because V6 is not as highly available in the same way that maybe your V4 is, in terms of failing between two different service providers using NAT to overload. Yes, you're going to lose your session connections when the session flips, but that's okay, because most of the time that's outbound, not inbound, in terms of source NATing versus destination NAT. So I think those are things that all need to come into consideration if you're trying to figure this out. And I would say that we don't have a great answer on the V6 side in terms of maturity about where that fits right now. I think that's a fair statement.
Yeah.
And this is coming from someone who's obviously a V6 advocate, but sometimes you got to deal with the realities of where you're at. And I think the realities of where we're at with the given manufacturers, providers, and solutions that are out there, it's going to be really difficult to have something that is addressing the same needs as where things fit with V4 today. That's just reality. I guess that dovetails in really nicely with the next listener question, which was all about sort of the state of IPv6 at home. So if we go even smaller, and well, I don't know, maybe some people's home networks are way more sophisticated than some people's commercial or small business networks, which is probably true for this audience.
Says the guy who used to run a MPLS internal home network, and before that it was 100% open flow.
Yeah, back in the day, running BGP over Gate D to the house. I was like,
oh man, I just have some flashbacks to Gate D.
But for most people's common home networks, I guess we'll talk about it. The listener question is, hey, is Slack the only reasonable choice for home LAN? Can I go V6 only yet? Or how close are we? And what's the adoption support for going on for home ISP routers and small business printers and IoT devices and, everything else? I guess I'd like to start with the last one, which is the IoT device stuff, because I actually think there's more progress there on that side of the camp than anywhere else in regards to V6, because you see the thread and matter stuff that's coming out. And there are a tremendous number of devices. All the Samsung smart home devices are all IPv6 capable via Matter, and all the Apple devices. There's so much stuff that's going on in that particular arena. I do think that's one area that is a strong suit for IPv6. But what's interesting about all those solution offerings, they really don't care whether you're on the global unicast IPv6 internet. It's all about them doing discovery for local devices to be able to do some of the smart things for discovery and smart things for interfacing and exchanging. And that can all happen on the same layer 2 segment, which for most home networks is going to be a single VLAN or a single LAN network, right? Wireless and wired probably all bridged together. One big mess, and that's what that is really designed to help support. So I think there's some actual sort of structural advantages for using those there. And I would say the rest of it is a very mixed bag in terms of what you're going to get from home routers and printers and other devices. I flat out know that, some of the TVs and stuff like that just won't work with V6, even if V6 is enabled. It's not functionally something that it operates with. It'll only grab a V4 address and not do anything with V6. And your mileage is just going to vary, and you're going to have to pay attention to what products you're picking up. I don't know. What do you guys think? Anything else to sort of add?
I spend a sort of shameful amount of my own personal time messing around with this kind of stuff. And I would say that, by and large, the average home user is one service provider, one gateway device, and then probably one segment inside their house, right? That's the 99%, maybe 98. And for that, I would argue that V6 is easy. Like, you can turn it on. It's probably on already if you're using a large provider piece of CPE, because a lot of the big providers are trying to push people over onto V6. So that just works. right? It uses Slack. Your devices that get V6, and they use V6 because that's what source address selection says. And if anything else is there, it gets V4 and it just goes and plays at the kids' table, right? And I think that's probably the biggest percentage. But what I've noticed in the space of IoT is that a lot of stuff is rapidly adding. Modern things tend to do V6. Like I had this personal crusade with Roku for years where I would just every 6 months, I would go back to this thread that I had on the Roku site, Roku's streaming device, for those that don't know it, and it wouldn't do IPv6. Well, they finally added it. You have to turn it on. It's like a very cryptic mechanism for turning it on, but it's there now and it does work. Both of the smart TVs that I have do V6. My Apple TVs do V6. My little print scan copier that I've got, I'm pointing to it, then this is an audio podcast. Rest assured, I'm pointing at something. It does V6, but only does Slack. My laser printer does not do V6. So I think there's a large amount of things that do it. Like a lot of the consumer grade cameras and things like that, Ring, doorbell, Roomba, stuff like that, it's not going to do V6. But like there's a shocking amount of things that do it now that within the last 2 years have added it.
I don't know, Tom, what your experience has been on the home side, because I mean, obviously we're all networking geeks and want to play around with V6.
Yeah.
It's hard to sort of evaluate where other people are at around some of that. And I don't know if you have much experience around.
Yeah, definitely. I mean, I've had Cox here at the house, been tempted to move to another provider here, living in a large urban area. You've got some choices, probably not the case everywhere, but, switching to CenturyLink as an example, and very explicitly making the decision not to do that, even though I can get much cheaper bandwidth because CenturyLink uses 6RD, which works perfectly well. But with Cox, I actually get a prefix and it's pretty stable. And so when I'm labbing things up internally, I know that prefix isn't going to move around on me and cause me to have to do some reconfiguration. So as you say, we're kind of a special case in that I'm paying close attention to that. I have like a Mikrotik router front end just so I can geek out and play with all the options that are available, as opposed to just using whatever out of the box, router.
Yeah.
/ wireless AP combo that Cox would foist off on me if I just let them. So yeah, from my perspective, the biggest concern was really just about getting that prefix and having it be stable and something that I can play around with and not have it move around a bunch.
Yeah, that being said, I mean, I've had experience with both the Motorola and Aris platform boxes for doing Wi-Fi and Wireport, and I would say for V6, they work as designed and appropriate. They hand out that /63. Now, you're not going to get what Tom's probably doing, which is probably some prefix delegation and getting some other stuff working, but you can absolutely get a 64 working on your local LAN and have all the expectation that you will get functional V6 operating within your network. It'll probably be dual stack, so you probably also see some RFC 1918 or the service provider transition address space being utilized within your network so that they can overload their V4, and then you'll go back to some giant carrier grade large scale NAT solution for them to be able to get out for V4 related services, which is perfectly fine. Like that's not a problem, and that's maybe not perfectly fine for gaming, but most of the gaming folks have gotten on the V6 bandwagon and realized that that's a better way to be able to do direct peering and get all of that sort of functioning. So they solved that a long time ago, and in fact, I think early on that was really sort of Xbox's big move for like getting Teredo in an Xbox and everything else, right? Was to be able to bypass a bunch of that sort of stuff and get out of the business of worrying about whether the service provider had you behind the same large scale carrier grade NAT configuration as your buddy down the street that you wanted to play first person shooter with, right? So those sorts of things I think are pretty much solved in that space. I guess it's the same structural problem that you have with what we just mentioned a little bit ago with a small to medium sized business, which is translation. If you're not in a dual stack scenario and for some reason your IPv4 isn't working, which could happen, that's reasonable. Your V6 could be working, your V4 couldn't. We really don't have service providers that at least I've seen from a solution basis that really come out there and say like, oh, here you go. We're providing NAT64, DNS64 capabilities. We're providing native translation capabilities. We're doing, CLAT and PLAT, which, granted, most of the Windows machines don't support, at least at this point in time, but Apple and Linux devices do and Android devices do. So it's sort of like, oh, well, why can't we make use of that? Well, the reason you can't make use of it is because it's not there. So
there's also, from the service provider perspective, I talk to a lot of small service providers just because I like that kind of stuff. I came from that world originally, a million years ago, and the technology is still interesting to me. One of the questions I've been asked a couple of times is, if you say we have to do V6 or we should do V6, why do we also have to do V4? And I think there are ways to do it with V6 only, but what you have to account for is that you cannot guarantee that a customer is not going to have devices that only do V4.
Right.
Right. So you have to be able to provide like a network level CLAT at the customer edge. Like, let's say I've had it in my house, like my little ONT would need to do CLAT so that the V4 pieces inside my house can go over a V6 only network and get to something else. And that's where there's a huge gap.
Mm-hmm.
If you're a gigantic fiber to the home customer or a humongous cable customer, you can just tell Motorola, we're not going to buy any more of your stuff until you give us the capability to do this. But when you're a medium-sized service provider or a little service provider, you got no option for that. I put a link in. There was a very early, I think it's a WISP, that actually rolled their own and did their own deployment of this in, I want to say Arizona. I think it's New Mexico, actually, that, is probably still running at this point. But for those customers that, don't have that ISP, there are public NAT64, DNS64 systems that you can use with all of the security baggage that goes along with, hey, I'm shoving traffic through a router, that's run by somebody else. I mean, I even run my own public NAT64, DNS64 that people can use if they want. They do exist out there, but obviously you're handing out your traffic to a third-party router somewhere, and you're also probably handing performance, to the not great performance.
Yeah, you're skipping through someone else's network to be able to get there. So in some cases, that's perfectly a reasonable trade-off.
Yep.
But I think the more important thing is from a home ISP router, if you're just getting what's provided by the actual ISP themselves, I think you're probably going to be fine and you're going to be able to work with whatever they're supporting. And if they claim they support V6, you're probably going to get V6. And it's really up to them to have the supportable model there. You're probably going to be dual stack. So the concerns about translation capabilities really probably aren't there, right? In the same way. And that's that. Now, if you're more sophisticated and you're maybe a home user that's got multiple service providers, you're in a different category. And go back to our question that we just covered earlier around SMB and IPv6.
Yeah.
And you're stuck in that same situation there.
I mean, I would go back to my original statement of for 99.9% of home users, V6 is just a thing that's on.
Right. Yeah, I would agree.
You're going to use it. It's going to be no problem. It's just going to work. And you're just going to run dual stacked and everybody's happy.
Yep.
And your family has no idea.
Nor does your refrigerator.
Right.
Awesome. Okay. And then let's jump to the next one, which was sort of an interesting, more down in the technical weeds a little bit than maybe the first two questions, which was really about sort of, hey, were we going to do anything covering Path MTU discovery with IPv6? Are there any caveats, tips? How are we thinking? And we could potentially have a, IPv6 basics, cover the basics around Path MTU discovery and chat through it. But I figured we'd talk about it really quickly. We have talked about it in other shows, but we haven't had a specific show, I don't think, on Path MTU. So I guess we'll start with the problem space. And the first problem space around Path MTU, and I guess the reason we need it is because we don't allow fragmentation in the same way that we do in V4. I guess that's the fundamentals about why Path MTU is a thing for IPv6, or at least one of the reasons.
In the network, got to be clear, as opposed to at the end state, endpoints.
Yeah, in network. So the endpoints can fragment to their heart's content, but the requirement is that you don't have an intermediate router that's going to fragment on your behalf, and then just the end device says like, oh, well, I'm getting more fragments. I just do the reassembly on my side, but the router took care of it in between. That process does not exist in V6. Good, bad, or indifferent doesn't really matter, just doesn't exist. So the end host devices have to figure out how to do fragmentation, which means they need to know the size of the MTU that exists between them in the direction of flow from source to destination, and then the reverse has to happen the other way. So they don't necessarily have to match, right? That's the other thing that's a little weird. So you're going to have to go back and forth. And that's the whole Path MTU discovery. There's a whole process in IPv6 for basically finding the maximum size MTU that you can use sort of hop by hop through the path to get from one device to the other. And we do that with ICMP version 6 messages to be able to sort of determine what those things look like. And the strange thing is that we have to allow routers in between the source and the destination to be able to send a message back that basically says like, hey, I saw your packet come through. And guess what? It's too big to get across my interface. I would like you to readjust your MTU size down to X. And I'm just a random router that you don't know. And that seems to freak out security people. They're like, we can't allow those sorts of ICMP messages to come back. Someone could abuse our relationship and tell us something different. And so there are lots of discussions that go on about how to secure and do sort of ICMP best practices for IPv6 so that you don't expose your network to undue message types or floodings of packets, et cetera, et cetera. But that's the reality, is that Path MTU is all about discovering the size from the source to the destination. Anything you guys want to add? Did I get that mostly right? Is it my IPv6 mostly answer?
Sound exactly right to me. Yeah. The fact that you aren't doing fragmentation somewhere along the path, I think personally that took me a while to sort of wrap my mind around, and I didn't really understand how it knew to do that, right? And that's basically what PMTUD does.
Yeah.
But yeah, that's a significant difference from V4 that exists at V6. That is one of the reasons you got to be careful when you mess with ICMP.
Yeah.
V6.
So I guess let's talk about what the tragic outcomes are if you don't enable Path MTU discovery.
Tragic outcomes, packets, just fragments all over the floor. What a mess. Get the mop. Yeah. Well, and I guess really from an administrative standpoint, the $64,000 question is, where is the path? Like, what path are we talking about? Is it a path within your internal network? Is it a path within your autonomous system? Is it a path between autonomous systems? Interdomain, path MTU discovery? Because the larger the radius gets there, the harder it is to sort of guarantee that PMTUD is going to actually work properly, that everybody's going to have ICMP v6 configured and enabled and allow PMT to do what it does.
Yeah, the tragedy of the commons is here again.
Yeah. Have you guys run into that in the last couple of years? I actually haven't seen a whole lot. I mean, early day V6,
it was horrible.
That was like the
Wild, Wild West.
That was like a chronic illness. Just you couldn't, but I haven't seen it in quite a while.
I think people have gotten better about understanding the operational principles of why Path MTU discovery is important and why they need to set their ICMP values the way they are. And I think the operators have figured out, to a great extent, at least for the service providers, have figured this out and put all the right controls in place. I think as enterprises start to migrate over to V6, I think we'll probably see a little spike or a little surge again of folks that didn't quite understand the lessons that were learned on the service provider side, didn't have that knowledge, took the exact same rules that they wrote for IPv4 and splatted them over into IPv6 and said, we're good. And then, wonder why their performance is not what they expect.
Yeah, I think we'll see one of two things. This is actually brings back up a memory of one of the first IPv6 endeavors that I went on. I was just, messing around doing things. And there was one part of the network that had always worked. And I couldn't figure out what was going on. And I think we'll probably see a similar type of dichotomy, as more enterprises adopt it. The reason it was working so well is because it was not understood how to do parity protection ICMP filters for V6, because you want to match, right, as closely as you can your security policies. So there just weren't any. So it all just worked. And I think we'll probably see some of that, as more enterprises deploy it, if they are smaller and maybe don't have a dedicated security team or whatever, they either forget that they need to do ACLs and, whatever for V6 that exists for V4, or they don't understand how to match them. They'll either match them too far and it won't work, or they'll not do it or won't go far enough, or in a rare occasion, they might do it exactly right, and then it kind of just works.
Yeah, Goldilocks there. I think to Tom's point, you're going to see variability. So within internal LAN infrastructure or data centers, I think you'll see very high performance because most people are probably they're probably using jumbo frames and, their MTU is probably trying to maximize the data throughputs that they're getting within their network. They're probably paying attention to that. And they're probably not as concerned with ICMP packets flowing back and forth at that point in terms of filtering. So they're probably, as you said, Nick, probably got it wide open, right? And letting things go as they see fit within their own sort of controlled wall guard of infrastructure. And then as they expand that out into maybe WAN infrastructure, you might see some different settings, right, Tom, in terms of what might happen across an MPLS provided network or across, an SD-WAN provision provided network. And so there are different things that might occur in terms of how that stuff works. And how that works over tunneling is a whole different animal we're not going to talk about.
Well, we've always got artisanally crafted tunnel mesh networks, and you're welcome to do the same thing with MTU. There's no reason you have to rely on MTU discovery. You can artisanally craft your MTU from one end to the other end of the network. You've got enough hours in the day.
Yes. Decrement by 16 by...
That's right.
What is it they always say? It's always MTU unless it's DNS. I think that's a Kevin Myers quote. But, for those folks that are running jumbo frames, they probably understand, like, I'm going to have to sit down and think about this particular vendor. I have to set it at, 9116. Some pad and some don't. And so if they have that kind of experience, then they're probably going to understand, like, I need to take into account all of the...
Yeah, my maximum segment size matching to my MTU and what the delta is.
Exactly.
Yes, I'm figuring it all out. Do the math, do your homework, show your work.
Unless you're like the network Neo, in the Matrix, and it's just all transparent to you. You just see the columns of numbers flowing down. And you're just like calculating it all on the fly.
Everything is 1280.
Yeah, that's the trick. It's all just 1280.
Yeah. I always think of the Futurama episode where Bender has a nightmare and it's all ones and zeros. And I think I saw a 2.
Traumatizing.
All right. We're going to close it there because maybe we'll cover Path MTU as an IPv6 basics show. So we can dive into the weeds a little bit more around that. But yeah, now if we really appreciate the feedback, the questions that come in. As a reminder, everyone can go to packetpushers.net/FU, and the FU stands for follow up. Just to be clear. And we'd love to be able to get any listener feedback, any questions that you folks have. We try and drop these episodes in here and there just to get these answered. And we really appreciate getting them. Thanks so much for listening. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long, and until next time, we'll see you on the IPv6 internet.